Okay, hi everyone. We're going over the multiple choice no calculator section. And again, these were kind of ordered with similar questions by topic. So let's go ahead and look at these. Okay, question number 5. I think that's the first one that I had. So I see this question and I'm thinking, oh crap. That's how I see these. Whenever I see, I think, oh crap. And then I think, U sub, it's integral. Maybe I can use U substitution. And the thing is, which are you going to pick for U sub? And I'm going to guess, I'm going to pick what's the inner heart of the most inner heart here. I'm going to pick the e to the x, or e to the x part. So that x part is going to be square root of x. So the integral would be u is equal to the U substitution would be square root of x. Du is equal to, if you want to rewrite this as x to the 1/2 power, if not, you memorized it already, to be 1/2 square root of x. Okay, if you memorize it, perfect. That's just as good. But if you don't remember it, let's do the derivative. d over dx of x to the 1/2 power is 1/2 x to the -1, right? So that's negative 1/2. Negative 1/2 means it's on the denominator, squared on the denominator. We multiply it over. Dx is equal to 2 squared of x du. We substitute it in. So the integral of e to the u, 2 square root of x du over square root of x, and we see that these x's cancel out. Wonderful. The integral of e to the 2, throw the 2 out, of du is just e to the u, with the 2 in the front, plus c. Replacing the u back, it's 2 square root of x, e squared of x plus c, which is our answer A. Okay. That's fine. The next question, let's look at number 7. Now, hopefully you guys are actually feeling like you guys are getting a little better at this. Yeah, hopefully you guys feel like you're getting a little better at this. Now, this problem here is a weird, interesting problem. They're asking us specifically, what's the integral? Now, I wonder if you guys remember this integral. Okay, if you don't remember, look at your cheat sheet of all your integrals, and if you can find something that's an integral of 1/1 plus u squared du. Okay, and that's actually what this one is. If I take the derivative of e to the x minus 1, that probably might cancel out the e to the x on top. I don't know, but I'm just thinking maybe that might be it. But if I say u is equal to e to the x minus 1, du is equal to e to the x dx, right? E to the x dx. And then so dx is equal to du over e to the x. We replace dx with dx here. Integral from 0 to ln of 2, 1 over e to the x over 1 plus u squared. And then we're replacing it with du over e to the x. We see that e to the x cancels out. And we're left with the integral from 0 to ln of x of 1 over 1 plus u squared du. This is an identity for us. I think that's arctan, right? I think it's arctan. And then so we have arctan, and then we're going to plug in arctan of u, plug in 0 and ln, natural log of 2. You can plug it in arctan ln of 2. Arctan ln of 2 minus arctan 0. The arctan of 0, if you look at, these are sides, if you just remember these are sides, what angle gives you a tangent of 0? 0, 1, 1. That's a 0, right? So that's angle 0. So that's your answer. Okay, so I messed up. I forgot you have to replace with the e to the x minus 1. You have to replace that back. and then you plug this into here. Oh my goodness, I made a mistake. You're right. I was thinking about that, like, but then I got caught up in the u. Arc tan, and then e to the ln of 2 minus 1, okay? And then this is minus arc tan e to the 0 minus 1, okay? So that's what we were supposed to do. Thank you for catching that. Oh gosh. And then this happens to be 2 arctan of 2 minus 1 minus arctan of 0. So that's still 0 for us because that's 1 minus 1. And then what's the arctan of 1? 1 square root of 2. Arctan of 1 is pi over 4. Oh my goodness. See? Oh my goodness. Killed it. Hey, Bobby, you have a question? So the e to the ln here, if you remember, they're inverses of each other. So e to the natural log of 2, they cancel out, and that's just 2.
What about the pi 4 one? How did you get pi over 4?
Okay, good. So if I say arctan of this arctan of 1, what angle gives you the tangent is equal to 1? So look at this triangle here. The tangent is 1 over 1. Is that okay?
Wait, isn't that? Wait, I don't. Which
So
does it? Are you talking about the quadrants?
yeah, that's part of it. Yes, yes. So in what quadrants is tangent positive? It's positive in quadrants 1
And
and
3?
3. That's right. You remember that. Perfect. But for arctan, it only works with quadrant 1 for tangent. Sine is quadrant 1 and cosine is quadrant 2. So we can ignore quadrant 3 when I'm using the arc. Okay. Now,
What about arc 0?
arc 0. Okay. If I draw you, we drew it over here in quadrant 1. What triangle would give you the sides 0 over 1? And if you look here, it's 0 over 1. It's a 0, 1, 1 triangle. And that angle is 0 degrees.
Huh?
That angle would be 0 degrees because it would be sitting on the floor. So arctan takes sides of a triangle and brings them back to angles. So tangent takes angles and makes them into sides. Arctan takes sides and makes them back to angles. Okay. All right. Thank you again for catching that. Are we guys okay? That's pi over 4. That was the answer. My mistake. And of course, I fell for the distractor because I was talking. I was telling myself in my brain, don't forget to change this back to the e to the x minus 1. And then I went and I forgot about it. All right. I totally forgot about doing that. Dumb distractors. But that was a good question. Okay. Our next question that we were asked is number 9 and 10. Let's go ahead, 9 and 10. Oh, just one more thing. The 2 last questions that we covered were not hard questions, okay? These are pretty easy if you knew how to solve it. If you knew how to read the question and you realized that was a U substitution problem, these weren't supposed to like be ripping out your hair type of problems. The second one was a trick problem though. Like you had to remember to resubstitute the e to the x minus 1. Okay, let's look at see if this is a hard problem or a trick problem. An object moves along a straight line so that at any time t, its acceleration is given by this function. Great. 6t. Let's go. 6t. At t is equal to 0, the object's velocity, they're telling us the velocity already at 0 is 10. And the position is, let's call it x of t, is 7. What is the object's position at t is equal to 2? All right, so we have to go back and find what our x of t is, and then plug in x at 2. So how do we get from acceleration back to velocity and then back to position? It's all integrals. So let's go ahead and set up the integral of 6t dt. To go backwards gives us 6t squared over 2 plus c. Let's go with that. We want to make sure we get what that constant is. So if t was 0, velocity at 0 is equal to 6t squared, which is now 0 squared over 2, plus c is equal to 10. Okay. So that's just 0. C is 10. Great. So our velocity at t is equal to 6, or that's 6 divided by 2 is 3, t squared plus 10. Right, let's take the integral of this guy to go backwards. The integral of this, so our x of t is equal to the integral of 3t squared plus 10 dt equals to 3t cubed over 3 plus 10t plus c. Are you guys okay with it? It's just really working those integrals really fast, just the power rules. And then we go ahead and we say this is okay. We're going to go ahead and plug in our 7 now. So when t is equal to 0, so x of 0 is equal to 0 cubed plus 10 times 0 plus c is equal to 7. So since it's all 0, c is 7. All right. X cubed plus 10t plus 7. That's our function. And then they want us to plug in 2. So x of 2 is equal to 2 cubed plus 10 times 2 plus 7 is 8 plus 20 plus 7 is 1535. Hey, that's an answer. What? Okay, so we're looking at this question number 2. The function f is given by the function sine x plus 1x squared. Which of the following statements is true? Okay, so first thing I'm thinking about sine graphs, just in my brain, I'm just thinking about what a sine graph looks like. And it could really change, but I'm thinking, look, a sine graph kind of looks like that, okay? Sure, whatever. But we can't have zeros. If we divide by 0, that's going to show off to infinity, okay? So as x gets closer to 0, what happens to the sine graph? Well, okay, let's look at this first thing. We have the graph of f has a horizontal asymptote at y is equal to 0, okay? So as x gets bigger, what does the graph tend to? So as x gets bigger, so what does the graph look like as x gets bigger? As x shoots up, would you be okay that this goes to 0? Everyone can kind of see that? Looking at that fraction, this is an algebra 2 pre-calculus skill. As x gets bigger, 10, 100, 1000, doesn't that bury x plus 1? So you would be okay to say, hey, as x gets closer to infinity, the x plus 1 over x squared, this tends to 0. Now, what's sine of 0? That's going to be 0. So we can say, as we go to the right, that for sure is 0. How about to the left? Would that also be 0? If I plug in a negative, over a positive, isn't that still going to be 0? Right? That's our horizontal asymptote rule from rational functions from algebra 2 and pre-calculus. That would also be 0. Okay. So we know for sure this is true now. Is it true that f has a horizontal asymptote at 1? No, we just said they're both going to be 0. And regardless of plus or minus, whichever direction we're going to, 0 plus 0 minus is still going to be 0. And then the graph has a vertical asymptote at 0. Is that true? We know that we can't plug in 0, but it's true that we end up with a vertical asymptote. Remember, a vertical asymptote, the graph goes to infinity. Now, is sine of infinity, right? Is that going to be infinity? No, this is actually, remember sine graphs? They kind of go like that forever. So in this case, no, that's not going to be okay. That's not going to be what it is, okay? So that's not an answer for us. So our only answer that we got is actually the first one. So they kind of give us a hint too. It's for sure we know it's not 2, and we know for sure it's not 3, and 1 and 3 maybe, and we know for sure it's not that one. So if you had a 50-50 guess, this is either going to be this one or this one. And again, this one is it's not a vertical asymptote rule. Right? If this was 1 plus x over x squared by itself, yes, we do have a vertical asymptote at y is equal to at x equals to 0, but not when it comes to the sine graph. Okay, the sign graph for us is yeah, just doesn't exist there at that one point. All right, let's jump to 20. Okay, let's jump to 20. The particle moves along the x-axis so that at any time t is greater than 0, the velocity is given by this function. If the position of the particle at t is equal to 1 t over 2 is, I'm sorry, let me switch it, is 4, what is the particle's position at t is equal to 0? Okay, so this is similar to what we did over there on for question number 9. We have to go from velocity back to position. And then once we have the position, we can then find the t is equal to 0. Okay, so to get back from velocity to position, we take the integral. So the x of t is equal to the integral of sine of 2t dt. When we take the integral of this, I'm going to use u substitution because that's stupid 2 there. But if you memorize how to do this instead, you can probably just say 1 over 2. But I'm going to just write out 2t. The derivative du is equal to 2 dt. dt is equal to du over 2. So I'm taking the integral, it's going to be integral of sine u, and then dt becomes du over 2, okay? So we end up with a 1/2 in the front, integral of sine of u du. The integral of sine u du is cosine, so it's going to be negative cosine u plus c. Let's go to plug back our u, negative 1 over 2 cosine of 2t plus c, okay? Now we have to plug in this to find out what our actual equation is. So let's go ahead and plug it in. This is xt, x of 1 pi over 2 for sure is negative 1 over 2 cosine of 2 pi over 2 plus c is equal to, where for sure this is equal to 4. Right? Now, what's a cosine of pi over 2 times 2? That's going to be a cosine of pi. If you remember unit circle, here is pi. What's a cosine? What's the x value? That's going to be negative 1, 0. That's going to be negative 1 first, negative 1/2. And this is going to be negative 1 plus c is equal to 4. Negative 1/2 plus times 1 is negative 1/2. 1/2 plus c is equal to 4. So c is equal to 3.5. See if I messed up along the way. 1/2 times 2 is pi. Cosine of pi. What's a cosine of pi? Here's pi. Cosine is negative 1. Forgot to write the negative part. Okay. So I'm getting 3.25, no, 3.5. So what is the actual time at 0? Okay. So let's plug it in. So x of t is equal to negative 1/2 cosine of 2t plus 3.5. That's what I'm thinking right now. So if I say what is x of 0 is negative 1 over 2 cosine of 2 times 0 plus 3 over 2. So what's cosine of 0? Cosine of 0 is just 1. Negative 1/2 plus 3 1/2 is just 3. I'm getting the answer is 3. And I need affirmation. Right. Yay, thank you for affirmation. Oh my goodness. But all these questions are just like, a lot of algebra that we might mess up on. But let me ask you this general question. Did this question, when you first looked at it, look a little confusing? Like, does all this stuff here, fluff, feel a little confusing? And personally for me, it is. It's a lot of stuff going on. T is greater than 0, the velocity, then once you find the position, they give you initial conditions. But the math part, that's pretty straightforward, right? and us remembering to plug back in the initial condition, and then some algebra. The only part that I was actually really scared about was the algebra part at the end. I was like 3.5, is that right? And then when I plug it back in, that's where we probably could make a mistake. Good job though. Okay, any other questions? Okay, let's take a look at number 16. The speed of a runner in miles per hour on a street trail is modeled by this crazy function, okay? Where m is the runner's distance, okay, in miles from the start of the trail. What is the maximum speed the runner speed of the runner between 0 and 3? Now, okay, just to make sure we understand, the speed of the runner is this model here. That's a velocity, okay? And the velocity is based on this meters, so the distance in miles. And they want us to find out what is the maximum speed of the runner. So what's the speed? Isn't that miles per hour? Right, that's what our speed would be. So let's go ahead and find, okay, the speed of runner in miles per hour. Oh, is modeled by this, where m is the distance in miles. So this is a weird question. The speed of runner is miles per hour. Right, we got that. On a straight trail is modeled by this equation here. Modeled by this equation, where m is the distance. The speed of a runner in miles per hour on a straight trail is modeled by that. Y is, what's the maximum speed of the runner? To find the maximum speed, we're going to take the derivative and set it equal to 0. Now, my slight confusion is the speed of a runner is modeled in miles per hour on a trail modeled by this equation, where m is the distance, the speed, where m is the runner's distance in miles. My problem is that miles part right here. Because if I take the from the distance from the start of the trail, okay, so his speed is changing based on. So what is the maximum speed? For us, the maximum speed is, I think you take the derivative, but then the derivative, that is the velocity. The velocity function is, this is one of the weird ones, but let's try to figure out maximum speed of a runner. I want to maximize a function, so I take the derivative and equal to 0. So if I take the derivative and equal to 0, it's going to be, so we want to find the maximum of something. You take the derivative of it, and then you set that equal to 0, because they want to find the maximum speed. So let's say whatever the graph is, where that derivative of this graph is, that is our, and it changes from positive to negative, that would be a maximum. If it goes from a negative to a positive, that would be a minimum. So since I want to maximize the speed, and this is the speed, I'm going to go ahead and take the derivative of this guy and set it equal to 0. So f prime of m equals to, that's a constant, and we're 1 over 10 on the outside. And what's the derivative of it? It's going to be negative 6m squared plus 18, it's not 18m minus 12, and ignore the constant. So this is 1 over 10. I'm going to factor out a 6. They all have a 6 here. I'm going to factor out the negative also. So I'm going to take out a negative 6. And we're be left with m squared minus 3m. 3m. And then divide by negative 6 is plus 2. Okay. Two numbers that multiply to become 2 are 1 over This is going to be negative 6 over 10. We're left with m minus 2 and m minus 1. Okay, so our zeros for this are going to be at m is equal to 2 and m is equal to 1. So if I draw my timeline here, at mile 1 and 2, these are all between 3 and 0. Let's go ahead and figure out the signs first. If I plug in a number between 0 and 1, between 0 and 1 here, if I plug in a number between 0 and 1, this would be smaller, so it'll be negative and negative and negative. See how that was negative in the front? I'm getting that's going to be a negative. If I plug in a number between 1 and 2, that's going to be positive, negative, and negative. That's going to be positive. And then between greater than 2, that'll be positive, positive, and negative. That'll stay negative. So I'm looking for maximums. The maximums could happen at 0, or the maximums could happen at 2 here, right? Because it's, and then this is coming down. So this could have been a maximum. So let's go ahead and figure out what the actual speed is at these two locations. If I plug in 0, if I plug in 0, 0, 0, the answer is 7, right? Are you guys okay with me plugging 0 back into my original equation? If I plugged in 2, 2, 2, 2, that's going to be 1 over 10 negative 2, 2 cubed plus 9 times 2 squared minus 12 times 2 plus 7. That's 8 times 2 is negative 16. 2 times 2 is 4, times 9 is 36. 12 times 2 is 24. And so this becomes 24. That's 40, right? Negative 40. Negative 40 plus 30 is negative 4. 1 over 10 plus 7. And that becomes negative 4 over 7 plus 7 is something like 6 to the 6 over 6 to the 3 over 7.
Wouldn't it be negative 4 over 10?
Yeah, sorry, miswrote it. Sorry, negative 4 over 10, which is back to 6 over 10, which for some reason I was thinking in my brain. I'm looking this up. So the answer is, if you compare these 2 points, that could have been the absolute maximum. His maximum speed is actually when he started. So the answer is 7. This is 6.6, right? Which is an alternative answer. Okay. This was kind of annoying. The reason why I was confused, because I was trying to think that we're supposed to get the answer as miles per hour. But what happens is this function itself gives you the answer miles per hour. This is miles per hour already. I was trying to think about, am I supposed to take the derivative where we end up with miles per hour on the bottom? But the answer is no. Whenever you're asked to find the maximum of something, you just take the derivative of whatever that maximum is. So if they give me speed, take the derivative to find the critical points of speed. So as again, I was overthinking this problem. Whenever you want to maximize something, you take the derivative of that object. If they say find maximum position, take the derivative of position. Maximum velocity, take the derivative of velocity. Maximum weight loss, whatever the function of weight loss, take the derivative of that weight loss function. So you take the derivative of whatever they give you, and then you set that equal to 0 because we're looking for those critical points. If I plug in 1 and 3, you plug in 1 and 3. If I plug in 1, 1, 1, just to show you guys, this would have been negative 2 plus 9 minus 12 plus 7, and this is 1 over 10. This would have been 19. No. Yeah, 19. No, sorry. 12 plus 14. Negative 14 plus 9 is negative 5 over 10 plus 7. This would have been 6.5. which is my answer here. If I plugged in 3 into the problem, it's probably going to give us a 7.5 value. No, actually, I don't know. 3.5, if I plug in 3, just because we went down from it. So if we were like 6.6 here, 7, this one should have been down. So if we plug in 3, we should got a lower number. And just to show you guys, we don't have to do it. I'm going to just show it to you guys. If I plugged in 3 here, 3 cubed is 27. 27 times 2 is negative 54. 3 squared is 9. 9 times 9 is 81. And 3 times 12 is 36. And 54 and 36 is 80, 90, 90. Negative 90 plus 81 is negative 9 over 10. Plus 7 is 6.1, right? 6.1. That wasn't on there, but you can see of the 4 points that we did calculate, 7 was the largest, and 7 was right at the beginning. So whenever they're asking for maximums, don't forget the endpoints. Don't forget the endpoints. Okay, because you could have started up really high. In this case, we started up really high, we slowed down, we increased, and we slowed back down. Very tricky if we forget the endpoints. Okay. All right. Any other questions, folks? We are out of time, but if you guys have any more questions, I can answer them right now, since you guys have lunch now. If not, you guys are good, then I will see you guys later then. Okay.
Thank you, Mr. Ko. Have a
Thank
good
you
one.
guys. Bye.
Hey, Mr. Ko.
Yeah, Dev, go shoot.
Did you get my email about reopening the kudos?
Yeah, oh, okay. Let me do that right now for you. No worries.
Okay. All good. Yeah, I think for some reason I remember you did it for me, but then I think the day after we talked, they all closed.